So yesterday, as I was saying, we started at section 8.1. We reviewed the side names. What do we call a polygon with n sides? What about 27 sides? What about 7 sides? Heptagon. It's with an H. All right. We talked about a diagonal and how to draw a diagonal. And then we talked about interior angles, which were the angles inside of any polygon. And then we went to this. We did that activity sheet. And we worked on that activity sheet. And at the end of it, we developed a formula. And what was that formula we developed? 180. N. And what does N stand for? What did N stand for in that formula we worked on? It is a variable. What does it describe? Does it tell me, what is N? Is it how tall I am? Is it what time I wake up in the morning? What is it for us? Khalil? So, Khalil, that's the formula. The formula is the sum of the measures. But what does N stand for? No, it doesn't. Let me go back. If I give you an n-gon, what does N stand for then? The number of sides. Same thing. Here we have N again. What is N then? Yeah, N is the number of sides. Okay, so N is the number of sides. This works. This should be 180 degrees. Sorry. This works for any polygon. Does not matter how big, how small. Any polygon, this works. And we're going to use this formula today. You will need to memorize this, Mario. You will need to memorize this. Other way, please. So please circle this. Make sure you know it. We're going to have a quiz on this section fairly quickly. Okay. This is actually, the first section is the one with the most math in it. A lot of the other sections are a lot of properties. Some math, but not as much. All right. So find the sum. Sum means what? Yeah, add them all together. Of the interior angles of the following figure. So we need to find the sum of all of the interior angles. Okay? Well, first thing we need to do is we need to find what n equals. What is n again? The number of sides. So let's count. 1 side, 2 sides, 3 sides, 4 sides, 5, 6 sides. So n equals 6. From here, all we have to do is plug it in our formula. So what's my formula again? 180 degrees, please. Times n minus 2. And now we're going to rewrite it, but we're going to plug in my variable. So we get 180 degrees times, what do I plug in for n? 6. And then you guys can simplify. So it's 180 degrees times what? 4. Use your calculator. So you get 720 degrees for the sum of the, what type of angles are these? What type of angles are these? Interior, yep. For the sum of the interior angles. Be sure that you say interior, because we're going to talk about exterior in a second. Maybe tomorrow, maybe today, depends on how it goes. So 720 degrees for the sum of the interior angles. Does this make sense? All we have to do is plug in our formula, find out what it'll be. All right, can you guys do that one then? And then when someone finishes, they can do it on the board for me. It's probably not too important to draw the picture. Let's get there. All you need to know is the number of what? Sides. You're finished. Call me over and I'll check it. Get on the board. So Julio's labeling the sides. He says there's 8 sides. What do we call an 8-sided figure? Octagon. That's the one everybody remembers. I don't know why. I think it's octopus. I don't know why. For whatever reason, everybody knows the octagon. And then he plugs it in, and he saw 8 minus 2 is 6. 180. Can you have degree signs behind those 180? Because it's 180 degrees. Okay. The eraser. So 180 times 6 gives him 1080. And 1080 what, Julio? Degrees. Please make sure you put the degree sign on it. That's all you need to do. So this is the sum. This is the total, or sum, for all interior. Total or sum for all interior angles. Okay? Any questions for that? All right, a little bit harder. Not much harder. Find the sum of the interior angles for an 18-gon. Luis, what is my n going to equal here? 18? Let me just plug in. What is it? 2880? What? Degrees. So remember, this is the sum. This is the total. All of them, okay? Any questions about that? All right. Now, moving on. The sum of the measures of the interior angles. The sum of the measures of the interior angles of a convex polygon is 900 degrees. Name the polygon by its number of sides. So this is where we have to, now, different. It's not a 900 gon, because it would have been, it says 900 degrees, not 900 gon, right? So not 900 sides, but 900 degrees. So we're going to use the same formula, but now we're going to use it backwards, okay? So what's my formula again? What is it, Jasmine? 180 times. And what does that equal for us here? The total number of degrees. So instead of it being, so yes, last problem we found out what the total was. It was 2880. This time they're giving it to us. It says 900. So it's equal to 900 degrees. And now we need to find my missing n. Okay? You see how this is just the opposite of what we just did? Yes, no? What do I need to do first then? Okay? I got to find out what n is, correct? How can I do that? I need to get it by itself. You could do the distributive property. It's going to be easier if you don't, though. You could. It would be perfectly fine. What do I need to get rid of from the left side? 180. But it's not subtract because 180 is multiplied, right?
Yeah.
So I need to do the inverse. What's the opposite of multiply? So I need to divide both sides by 180. What happens on my left side? Are you okay with that step? So then I have to do what to both sides? Add 2. So n equals 7. Are we finished?
No.
Because why? Good. Make sure you read the question. So you get n equals 7, but that's not what I asked for. I said name the polygon by its number of sides. So go back. Take a look at 7. What is 7? A heptagon. So this would be a heptagon. Any questions about this one? Let's do one more. Can I borrow your paper? New problem. Instead of 900, I want you to find it for 2340. I want you to find it for 2340. Is this another practice? These problems show up on the ACT and SAT a lot. On the standardized test? Yep. As long as you remember to bring it. The other thing I'd recommend is you bring an extra set of batteries. So they're AAA batteries, and obviously we'll lend them out, but when you're a junior, you have your own calculator. And if it dies, if I'm even in the room and I've got batteries, I'm not legally allowed to give you anything. So, you think it's a joke, but it's happened to me. I've had a calculator die in the middle of an AP test, not a standardized test, but I had batteries in my backpack. So, yep.
Can you like leak it out for people who need it?
I don't think so. I don't think I'm allowed to. I think you have to have your own. Jasmine? Yep. So Jasmine, can you walk me through what you did here? Times n minus 2 equals? Okay. Divide by 180 on both sides. N minus 2 equals? What is it? Equals 13, and then what? Plus 2, so n equals 15. Are we finished? What do we need to name this? Yeah, 15 gon. Doesn't really have a good name. So 15 gon. Ladies and gentlemen, Khalil? What? So 15 gon has how many sides? How many angles does it have? Yeah, you're right. Think about a triangle. Think about a triangle. How many sides does a triangle have? How many angles? Think about a square. How many sides does a square have? How many angles? It's going to be always the same as the number of sides. Okay. A hint or a warning: you cannot get a non-whole number side. It would not make sense if you got 6.5 sides, right? So if you're doing your math and you get n is equal to like 3.1, you did something wrong, okay? It has to be a whole number, all right? You can't have 3.1 sides. It's like 3.1 people, all right? So you do those standardized assessments, like how many people would fit in the bus, and then you're like 32.7 people. Well, I hope I'm not the 0.7, okay? I hope I'm one of the 32.
Please don't have an arm or something.
Yes. But then we get into a whole lot of moral issues, Mario. I could consider them a whole person, even if they're missing just an arm. Alright? One more? Just to practice, one more? So you're going to use this formula, you just got to be careful about what they give you. If they give you a side, plug it in for n. If not, you got to solve for n. Start with the decagon? And how many sides does a decagon have? So n equals 10. Anybody get anything else? Cool? Before I move on, how many of you are going on the field trip on Monday with Ms. Schleicher's class? Okay. Sorry. All right, now, sometimes we have to find out what x is, okay? So sometimes we have to find out what x is. Well, this is a two-part problem. So the first part, step one, is find the total, or find the sum of the interior angles So step one is find the sum of the interior angles. You may want to draw the picture here too. Draw your picture. Step one is to find the sum of the interior angles. That's exactly what we've been doing, okay? Just like we've been doing. Write your steps. And then step two is to solve for the missing angle. Z. There might be more than one. Solve for the missing angle Z. Because there might be more than one. Here we just have one. Okay? Excuse me? It is a trapezoid. We're going to talk about those later in the chapter. So not only we're going to talk about not only recognizing them and naming them, but also what properties they have. So number one, find the sum of the interior angles. That's what we were just doing. So what is n here? And what do we call a four-sided figure? Not necessarily square, because is that a square? It's a big common mistake. When I say four sides, everybody says square, right? But that's not necessarily a square, is it? So 4, in general, you have to say quadrilateral. The quadrilateral means any shape with 4 sides, okay? So it could be a square, yes, but it could also be a rectangle. Or a trapezoid, like this one. So plug it into your formula. What is my formula, Moshi? 180 times n minus 2. What's n here? So 4 minus 2? You're right, Giselle? All right. So 180 times 2. So we get how many degrees? 360 degrees total. All right. Ladies and gentlemen, this is going to be very helpful. For a quadrilateral, it's always going to be 360. And that's something you should have memorized. Just like how many degrees are there in a triangle?
180.
You should now know that in a quadrilateral there are 360, okay? So that's going to show up a lot, so that's helpful to memorize. So 360 in a quadrilateral is helpful to memorize. Step 2 then, solve for the missing angle. So remember, I'm going to draw a little sketch up here. Remember if I had a triangle, and if I gave you this angle and this angle, could you figure out the third one? It's the same thing here, except now I just have one extra angle, yeah. So I need to add them all up. So I get 108 degrees plus 121 degrees plus 59 degrees plus what? X. How much does that have to equal? What is it? How do you get 288? So all of this is equal to 288, I agree. But what does the total have to equal? Just like a triangle. 360. So the whole thing is 360. Gustavo, you're absolutely correct. Remember, we're adding the x too. Okay? So Gustavo said he already added these three together. What was it again? So we get 288 degrees plus x equals 360 degrees. And you guys can solve that, right? So x equals 72 degrees. Does 72 degrees make sense with the picture? Why or why not? Raise your hand, please. Does 72 make sense with the picture? Why or why not? Raise your hand, please. Mario? Okay. Does it look like 72 could be correct? Need a reason why. Stephanie? Uh-huh. So what about the 59? I think you guys are trying too hard. Jasmine?
The angle pressure was smaller than 108 degrees.
Sure. So if you said it looks smaller than 108, I think you're still trying too hard. I mean, that's fine. Is 72 going to be obtuse, acute, or right? Acute. Does that one look obtuse, acute, or right? So they match up. That's all what I was thinking. I think yours is fine. It's going to be hard, though, for other problems. I would always just make sure that it matches up if it's acute or obtuse, okay? Any questions for this problem? One more? Go ahead. Before you start, though, what do these arcs mean? They're angles, yes. They're equal to each other. So if we don't know t, what should I name it? And what do we know about t and x? They're the same. So if this is x, what's that going to be? X. Okay, try and set it up using the two steps I gave you last class. Using the two steps. Do you need help? Raise your hand, please. That's n. What does n stand for? What does it stand for? All the time. Variable. What is the variable? It is a variable, but the variable has to stand. What does it stand for? Is it for height? Is it the time you get to school? Is it the number of teachers in the room? Is it number size? So n here, that's my spot for n, right? You finished raising your hand? Any help? No, it's okay. It's not your final answer. So you just did step 1. And you just do step 2. Well, they're going to be the same. So you can find that. What that's like. Okay. But what did you find for it? So step 2, remember, is to add up all your angles, and they should equal whatever you found in step 1. Or you could write x plus x. That's good. It was 360 here. How many sides does that have? So see how we found 360 here? Just had 5. So the first thing you need to do is find out step 1. So 540, right? And you need to add up all the angles and set each of one. 540. 5 sides. That was good, except x plus x. What do you expect? One more. One and there. So, you have 1. You have 1x. How many are there? Yeah, stop. You make sure that you need formula. It's 180 times what? We can do it for you. What? Step here. For your what? Uh-oh. No. You guys are sure? Get it off. I want you to be. I like that. What happens? N plus N. Oh, man. Plus N. No. And time that. So if I give you $1 and I give you $1 more, how many dollars? 2 N. So N plus another N is 2N. So Alright, take a look at Gustavo's work. So remember, the first step is to find the total measures. So you need to find the total, right? So we know this is no longer 360. Why? Because how many sides? 5 sides. What was 4 sides? What was 360 for?
4 sides.
And what about a triangle? 180, okay? So triangle is 180, quadrilateral is 360. I would know those two. And then after that, it doesn't really matter, okay? So, you use the formula. N, what does N stand for again? Number of sides is 5. Plug it in. So you get 180 times 3 is 540 degrees total. So all the way inside, okay? Then, add them up. 93 plus 156 plus 85. 93 plus 156 plus 85. See how you told those from this picture? Plus, he knew that there were 2 x's. Whoops. So he said plus 2x equals 206. Does that make sense? Yes? No? Okay? And then he did x is equal to 103. So he divided both sides by 2. How could you check this? Say that again? Add them all up. So you know these are 103, right? So if you add them all the way up, all the way around, it should be 540. Mackenzie, did that work? Yeah, so Mackenzie already did it, so that's great. Any questions before we move on? We're going to try something different next. We okay? All right, regular. This was a word we learned a while ago in chapter 1. Anybody remember what it means? Mochi? Same size, same angle. So in a geometric language, we would say it's equilateral. What does equilateral mean? Same what? Same side and equiangular. Equilateral and equiangular. Okay? So give me an example of a regular octagon. Stop sign. That's your basic one, right? In a sense, the regular ones look pretty. All right? If you see them, they look perfect. They're very symmetrical. Can I borrow your sheet? When we did this yesterday, all of these were regular. Did you notice that all the sides were the same? All the angles looked about the same? Okay.
Also, you're saying that the other ones aren't equal.
So we can have non-regular octagons.
Which aren't equal.
For example, that was an octagon, right?
Yeah.
But this is not regular. You see how side 6 is much longer than side 4? So it's not regular. A stop sign, however, would be regular because all the sides are equal. Okay? And it has to be the angles, too. So what is the measure of each interior angle for an octagon? So now, I'm not asking for the total. We did the total before, right? Now I'm asking for each individual angle. So once again, when we go back to this, how many sides do I have here? But how many angles do I have? 6. So we always have the same number of sides as we do angles. Is that everyone cool with that? So let's start this one, all right, for an octagon. So first I need to find the total number of degrees. So what's my total number of degrees? What's my formula? So it's 180 times n minus 2. Once again, have it memorized. What does n equal for me here? So n equals 8. Let's plug it in. It's 180 times 8 minus 2. So it's 180 degrees times 6. What does that give me? $1080. So 1080 degrees. This is the total. So this is the total. That means for every single interior angle, right? So far we've always been finding the total, right? We want to find the whole thing. Now I want to know for each one. Go ahead. Yeah. So it's regular, so that means are all the angles equal? So if we have 1080 degrees and we need to split it evenly between all people, or all angles in this case, I just divide it by the number of angles, right? So I have to divide 1080 divided by the number of degrees, which is n again, right? So divide it, not the number of degrees, sorry, the number of angles, which is n. And what does that give me then? 135? So that means if I draw a stop sign, alright, not quite perfect, but it's supposed to be regular, so all the sides are equal and all the angles are equal. That means that every single one of these angles is 135 degrees. Okay? Because they're all equal. Does the concept make sense here? See how we're taking what we learned a little bit before and making it just a little bit harder? The next thing I want to do is talk about how we can find a formula. So instead of an octagon, I want a regular n-gon. So let's say I don't know how many sides. Well, what did I do over there? What did I do over there? Let me cut up, please. What did I do over there? What was my first step? Find out what n is. But we don't know what n is, right? So what's my formula? 180 times n minus 2 equals the total, right? What did we do with the total after we found it, though? We divided it by what? Did we divide by 180? What do we divide by? The number of sides. Well, what is the number of sides? N. So if you take this and divide it by n, this is your formula. This is for each angle so a single angle, right? Just a single one. For each angle of a regular n-gon. So this is your formula that will work for all things that are regular. This is your formula for all that are regular. So I want you to do this problem again, but now I want you to do it for a hexagon. So solve that problem right now for a hexagon. So do it just like we did number 1, but now you can use your formula if you want. So for a hexagon, what does n equal? 6. Good. You finished. What'd you get? You gotta keep going. N equals 6, but I want each angle. So you're gonna plug it in to find each angle. People need help? Gustavo? 120? Did you get 120 right? Justin? So hexagon should be 120 degrees. That's for each angle. So just so everybody knows, what was n equal to? 6. So we plugged in 180 times 6 minus 2, so 180 times 4, and then you have to divide it by 6. Did you find your mistake? Okay. Your homework for tonight? Let me take a look. Homework for tonight, I want you to do 3 through 5, 7 through 9, 11, 12, yep, that's it. 3, 5, 7, 9, 11, 12. We have a quiz coming up, so we're not quite finished. We have tomorrow, we'll finish it up. What would you guys like to do in terms of the quiz? I can do it on Monday, but 4 of you would miss it. Do it on Monday, but 4 of you would miss it. I don't really want to push it that long. Who are those 4 that would be missing? Would you be willing to make up a 10-minute quiz for me at some point during break or lunch or something like that? Is that okay? Well, let's plan on this quiz being Monday. You'll be here for after lunch, but you'll miss the period.
I know what time I just think of.
Yeah, you can do that. That's fine. I'll have it ready whenever you want it. All right, can I get a calculator check, please? Everybody got the homework down?
Yeah.
Can I close it? All right, adios. Have a good day. I will see you all tomorrow.